Hi everyone. Today we are going to discuss Jacobian concept and example on Jacobians of composite functions. Let me start. So first of all, when you think about the concept of Jacobian of composite function, we have to just know that what is composite function. What is composite function? So let I am considering if u and v are the functions of xy, u and v are functions of x comma y and xy are the functions of r and theta such that suppose let me start here. U is equal to u is a function of here xy, means u is f1 of function xy comma v is also equal to a function f2 of xy and here xy is a function of r and theta, means x is equal to, suppose phi 1 is a function of r comma theta and y is equal to here phi 2 is a function of r comma theta. Then the Jacobian of uv with respect to here r comma theta, right, that is equal to Jacobian of uv with respect to here, first of all u is a function of here xy, therefore del by uv upon del by xy we have to calculate it into xy are the functions of here r and theta, so therefore this is del by xy upon del by r comma theta. So that is here u and v, u comma v are the functions of here x comma y and x comma y are the functions of here r and theta. Then this uv is a functions of r and theta, so that is called as composite function. I hope you have to understand this, right? So similarly if u is a function of here, suppose f1 of function x comma y, right, v is also function of here, therefore suppose x2 x comma y comma z, so I am taking here three functions is there, means if u and v are the, or u v and w are the three functions. So if u is a function of here x y and z, right, similarly v is a function of here f2 is a function is there x comma y comma z, similarly w is a function, that is f3 of function here x comma y comma z, and I am writing here also what is that here again x y z, so x is a function of suppose that function of x we called the another function, that is a notation for that function. So this is x is a function phi 1 of, means I am taking the another function, that is psi 1 of here r theta and phi, right, comma y is also another function, that is a psi 2 of, that notation is called as psi 2 of here r theta and phi, and also z is a function of here, suppose psi 3 is there, right, psi 3 of here r theta and phi. I hope so you have to understand this, means here clearly that is u comma v comma w are the functions of here r comma, means here are the functions of x comma y comma z, and these are the functions of r comma theta comma phi. So we called u v w, these are composite function guys, these are composite functions of r theta and phi. U v w are composite function of r theta and phi. So then what I wanted to write here, dabba u comma v comma w upon dabba r theta and phi, that is equal to, this is dabba u v w. First it is a function of x y z, therefore this is with respect to x y z, into dabba x y z, it is a function of r theta phi. So r theta and phi. Okay, so for two functions we have to define also composite function, and for three function we have to define also composite function. So in this way, and so on and so on. If you have been getting two or more functions or three or more function, you have to apply same things is there. So this is concept of Jacobian of composite function. I hope so you have to understand this very well. Right, now let me start example based on composite function. Let me start example based on Jacobian of composite function. Let's see the example first. First example I am going to discuss here. Right, so let's see, if u equals to here e to the power x cos y, v equal to e to the power x sin y, x is equal to lr plus s, y is equal to, so lr plus sm, so right, this is lr plus sm, y is equal to mr minus l, mr minus here ls. So these are the functions you have to given. Right, find the value of dabba uv upon dabba rs, dabba u comma v upon dabba r comma s. So how it will be find? Now let me start the solution. Let, these are the functions you have to given. Let u is given to you, that is e to the power x into cos y, and v is also given to you e to the power x sin y. So first of all you have to clear that x and r is what, and x equal to here lr plus sm, y is equal to here mr minus ls. So here what is that, u and v are the functions of here x and y, right? xy are the functions of here r and s. I am showing by using the graphical diagram is there. So u v are the functions of xy, therefore this u is a function of x and is a function of r. So let's see, so first u is a function of x and then x is a function of r. Also u is a function of here y and y is a function of here s. So similarly that v is a function of x and x is a function of r, right? Then v is a function of here y and y is a function of here s. So then what is that composite function? Then u is a function of r, and means this total both u and v, this total both uv are the functions of here, means this both u v are the functions of r and s, uv are the functions of r and s. So this is what, this is a composite function, this is a composite function. You have to just find out here, right? So where lm are constant, so where l comma m are constant. So let's see. Now we have to find Jacobian of composite function. So therefore to find Jacobian of composite function, find Jacobian of composite function. So how will you find the Jacobian of uv with respect to here Jacobian rs? So this can be done by using Jacobian of uv with respect to first xy, and the xy are the functions of here r and s. Understood this? So just you have to calculate first dA by uv upon dA by xy is what, and dA by xy upon dA by rs is what. So by using the definition, you have to just put up the values in this equation. So therefore let me start. DA by uv upon dA by rs, how can be written as this? So therefore this dA by uv upon dA by rs, this can be find by using dA by uv upon dA by xy and dA by xy upon dA by r comma s. So what is the definition I am writing here? So it is 2 by 2 determinant. DA by u divided by dA by x, dA by u divided by dA by y, dA by v divided by dA by x, and dA by v divided by dA by y. This is first determinant. Into second determinant, dA by x by dA by r, dA by y by dA by x by dA by r, and then dA by y by dA by r in the first column. Then in the second column, dA by x divided by dA by s, and here dA by y divided by dA by s. I hope you have to understand this. Right? These are the just definition apply here, right? So therefore, you have to first find out what are these 8 partial derivatives. So total how many partial derivatives? 8 partial derivatives. For consideration, we call that is equation number 1, right? So first of all, u and v is given. So let u is equal to, that is e to the power x cos y, v is equal to e to the power x sin y. So first of all, you have to find these derivatives. So dA by u by dA by x is equal to what? DA by u by dA by x, e to the power x derivative e to the power x, and cos y term is a constant, therefore this derivative as it is. DA by u by dA by y, that is equal to, this is what? That is e to the power x, treating as a constant here, right? And cos y derivative, that is a minus sin y. Next, dA by v by dA by x. So here again e to the power x sin y as it is, and dA by v by dA by y, that is equal to, here is e to the power x sin y derivative, that is cos y. Similarly, x is given to you. X is equal to LR plus SM, and y is equal to here MR minus LS. We have to differentiate this x with respect to r. So what we will get? The derivatives dA by x divided by dA by r, treating other variable as a constant, therefore it will take the only value is L, right? dA by x divided by here dA by s, so other variable keeping as a constant, therefore it will take the values only m. Next, dA by y divided by dA by r, it will take only m, and dA by y divided by dA by s, it will take minus L. So by using these values, so therefore substituting in equation 1 we get, so what is that here? dA by uv upon dA by rs, this can be written is in the determinant form. So so right, these are the 2 by 2 determinant, that is product of 2 determinant is here. So what is that in first determinant? The value of this as now in this way. So substituting all these values in equation 1 we get. Now let me start. the equation 1 now in next page. So therefore dabba uv upon dabba rs, it is nothing but it is a first determinant. You have to substitute the values is here. So what is that? E to the power x cos y, e to the power x cos y, then minus e to the power x sin y, right? Then e to the power x here sin y, and e to the power x cos y. That is the first determinant. In the second determinant, that is L m minus L, right? So therefore this is e to the power x cos y, right, into e to the power x cos y, minus, you have to just take its simplification of first determinant, minus plus is there, e to the power x sin y into e to the power x sin y, that is in first bracket, into in the second bracket, what is that here? Minus L, and here minus m, minus L square minus m square is there. So therefore what will becomes, I am taking e to the power x, or e to the power x into e to the power x, that is e to the power 2x. I hope so we have to understand this, right? That is e to the power 2x, e to the power 2x cos y, it will becomes cos square y, plus here again e to the power 2x, here sin square y, and that the term it will becomes minus L square minus m square as it is. So therefore this is a minus L square minus m square is there. So therefore e to the power 2x common, and inside the bracket what is that? Cos square y plus sin square y into minus L square minus m square, right? So you know the trigonometric identity, this is e to the power 2x into what is that here 1, right? And here minus L square minus m square. So since what is the reason here? Sin square theta plus cos square theta equal to 1, that is a trigonometric identity we have to use. So therefore this is equal to, minus taking common here, so this is e to the power 2x into L square plus m square. So therefore clearly dabba uv upon dabba rs, that is equal to minus of e to the power 2x inside the bracket L square plus m square, and this is your answer. This is your answer of composite function. This is required answer. I hope so you have to understand this very well. What is a composite function? What is the concept of composite function, and how to find the example on Jacobian of composite function. So let me discuss now here example number second. Let's see. So example number second. If x equals to a in bracket u plus b, y equals to b in bracket u minus v, and u is equal to here r square cos 2 theta, v is equal to r square sin 2 theta, find dabba xy upon dabba r theta. Find dabba xy upon dabba r theta. So let me start solution, right? So given that here x, y, u and v, right? We have to just find out dabba u by dabba x or dabba v by dabba. Means like here in a question you have to given x comma y are the functions of here u comma v, and u comma v are the functions of here r comma theta. Then this xy is a composite function of r and theta. Then xy is a composite function of r and theta. So let's see how it will be solved. By definition of this composite function, you know that you have to just calculate here dabba x divided by dabba u, right? Then dabba x divided by dabba v. Similarly, you will have to calculate here dabba y upon dabba u and dabba y upon dabba v. So these are the four values. You first calculate this. Also you have to find out dabba u divided by dabba r and dabba u divided by dabba theta, right? You will just take uv are the functions of r and theta. So again dabba v divided by dabba r and here dabba v divided by dabba theta. You must have to find out these values, guys. You must have to find out this value. So what is that dabba u by dabba x? By observing this means dabba x by dabba u, you have to just treating other variable as constant. So this is what only a, right? This is dabba u x by dabba u, dabba x by dabba u, dabba x by dabba v, that is also again a is there. Dabba y by dabba u, that is a b. You have to observe this dabba b, and dabba y by dabba v, that is a minus b, right? So you have to just observe this value. Now next value is what is that dabba u by dabba r, that is a 2r cos 2 theta, cos 2 theta, and 2 minus 2r square cos 2 theta. You just observe here dabba u divided by dabba r and dabba u divided by dabba theta, right? But I hope so. This dabba u by dabba theta, you know the value is sine 2 theta, because cos 2 theta derivative is what is that sine 2 theta, right? That is a sine of 2 theta, right? Next dabba v divided by dabba r. So this is a minus dabba v divided by dabba r with respect to r. I hope so. This is a plus, that is a 2r sine 2 theta, 2r sine 2 theta. Theta is a constant, and here dabba v divided by dabba theta, r square term as a constant, and sine square derivative, it is a minus. Sine square derivative is a cos 2 theta, means it is simply 2r square cos 2 theta, and using this value in Jacobian definition. So therefore, by definition of composite function, by composite function, how it will be find? That is a Jacobian of xy with respect to r and theta is dabba xy upon dabba r and theta. This can be written as, this is what is the formula, dabba u by dabba x. So this is perfectly I am writing dabba x by dabba u, right? So this is a dabba x divided by dabba u, dabba x divided by dabba v, dabba y divided by dabba u, right? And dabba y divided by dabba v. This is a first Jacobian with respect to r and theta. So let's see, I am also writing now in briefly. Means how to write this in deeply. So this is nothing but dabba xy upon dabba u comma v. First xy is a function of uv, and then uv is a function of r and theta. So for that you have to just write the definition form, that is a dabba x by dabba u, dabba x by dabba v, right? And dabba y divided by dabba u and dabba y divided by dabba v. That is the first determinant. In the second determinant, you must have to write here dA by u divided by dA by r, dA by u divided by dA by theta, dA by v divided by dA by r, and dA by v divided by dA by theta. Means uv are the functions of r theta and xy are the functions of uv. Just you have to put up this value. So equation number 1. So putting all partial derivatives in equation 1, we get. So let me write here. So therefore dA by xy upon r theta, this can be written as, it is a determinant of the values text here now in this way. That is the first dA by x by dA by u means a, then first row a, then b and minus b, is there. I hope so you have to understand this, right? Second, it is here 2r cos 2 theta. Next value minus 2r square sin 2 theta. Next value 2r sin 2 theta. And next one is, what is that here? 2r square cos 2 theta. 2r square cos 2 theta. You observe this very well. I am just already find out these values of all derivative and putting in equation number 1. So equation 1 once you check, equation 1 once you check here. So therefore simplifying this determinant, this is equal to minus ab, that minus ab, right, in a first bracket. In the second bracket, that is a 2r cube is there. So 2 into 2, that is a 4, that is a 4r cube, into cos square 2 theta. So angle is a 2 theta is there. So I am writing here cos square 2 theta. 4r cube here, cos square 2 theta, minus plus here 4r cube here, sin square 2 theta, right? So minus sign taking common, so that we get minus 2ab inside the bracket, that is a 4r cube is a common, and here cos square 2 theta plus sin square 2 theta. So what will becomes here, that is a minus 2ab inside the bracket 4r cube, and this is a trigonometric identity guys, since sin square theta plus cos square theta equal to 1, we have to apply here. So what will get your final answer, that is 8 abr cube, that is a minus 8 abr cube, minus 8 abr cube, and this is answer of xy divided by dA by r theta. I hope so you have to understand this problem very well. You have to understand this problem very well. Because of that, here we have to given first. Given xy are the functions of uv and uv are the functions of r and theta. Therefore, by definition of composite function, xy are the functions of r and theta. Hence the proof. I hope you have to understand this very well. Now it is sufficient for today. Thank you.